Good everyone. Want to look at the topic acid, base, and salt. Summary. Now, basically, the definition of both acid and base follows three theories majorly that we're looking at in this section. Now, basically, we'll be starting with Arrhenius theory of acid, which states that number one, acid is a substance that can dissociate to form hydrogen ion, or as you call it, that dissolves in water to form ozonium ion, which can also be called hydrozonium ion or hydronium ion. So you can also call it hydronium ion or you call it hydrozonium ion, the case may be. Now, an acid is a substance that dissolves in water to form ozonium ion or hydrogen ion. So basically, it's when acid dissociates that forms hydrogen. Categorically, this is an acid dissociates to form hydrogen ion. But this other one, NOH. Now, a base is a substance. Let's define a base first. A base is a substance, according to this theory, a base is a substance that dissociates to form hydroxyl ion, or a base is a substance that can neutralize an acid to form salt and water. A base neutralizes an acid to form what? Salt and what? And water. So if you also add this to water, we're going to have ozonium ion. So this is also an acid. So an acid is a substance that dissociates to form hydrogen ion, or a substance that is, maybe we dissolve it in water to form what we call ozonium ion. So basically, we have the Bronsted-Lowry theory, which is next. This theory states that an acid is a proton donor, while a base is a proton acceptor. So this will lead us to conjugate acid and base pair. We will need next the third one we're looking at. Before we go to this, we are going to look at Lewis acid. But remember, Bronsted-Lowry theory tells us that an acid is what? A proton donor, while a base is what? A proton acceptor. The proton we are talking about in this theory now is the hydrogen ion, actually. So anything that can accept hydrogen ion is called a base. Anything that can donate hydrogen ion, like this one that donated this hydrogen ion, is called an acid. So Lewis theory tells us that an acid is a substance that can accept a lone pair electron. So an acid is a lone pair electron acceptor, while a base is a substance that can donate a lone pair electron. An example of Lewis acid are hydrogen ion and ion this Fe2 plus, Bf3, then aluminium trifluoride, etc. and so on. But basically, in this theory, most cations can accept lone pair electron. So according to this theory, most cations are acidic. For example, now they can ask you, potassium ion is acidic according to which theory? According to Lewis theory, potassium ion can be acidic because it can accept a lone pair electron. Now let's look at conjugate acid and base pair. Now, conjugate acid is formed when hydrogen ion is being added to when you add hydrogen ion or a proton to a substance, you're going to form conjugate acid. When you remove hydrogen ion from a substance, we are going to have conjugate base. That's just the what's it called, the simple logic to get conjugate acid and base. Conjugate acid and conjugate base. For example, now what is the conjugate base of this CH3 COOH? If you remove not this CH3 is together. This H is the something like the hydrogen that made that compound an acid. So if you remove that hydrogen now, you are going to get what known as conjugate. If you remove, for example, now if I remove this hydrogen from this place, I'm going to have Cl minus. So that Cl minus that is being formed when you remove hydrogen ion from this place is called the conjugate base of this acid. Called what? The conjugate base of what? Of this acid. So if I remove this hydrogen ion, I'm going to have this. Take note of the sign. You're going to have, you have minus sign here, because H plus has been removed. If you add another H plus to this one now, plus and minus will cancel out. You have a neutral compound. Let's look at more examples on this conjugate acid and base. Now the conjugate base of H2PO4 minus. Take note of the sign. So if you remove one more hydrogen to this one, you remove one again from this minus, it will now be minus 2. So you're going to have HPO4 minus 2. Take note of the sign, very important. Conjugate acid of water. When you add hydrogen ion to water, you're going to have, the water was H2O before. If you add H plus, you're going to have H3O plus, which is the ozonium ion. That's what you're going to have. Now, conjugate base of water. If you remove one hydrogen ion from H2O, you're going to have OH minus. Take note of the sign, very, very important. When you remove hydrogen ion from a neutral, something like compound, after you have removed the hydrogen ion, what will be left out will be the radical, which is the negative radical of that compound. If it was negative before, if you remove hydrogen ion, remove one from the negative one that was already there, it will now be negative 2. So when you conjugate acid of this base, which is NaOH, if you add one hydrogen ion to this, you're going to have H2 then O. You will neglect this Na, which is the sodium. You know add this one to it again. So if you want to get the conjugate acid of this one now, neglect the sodium and add one hydrogen to that OH, you're going to have H2O. So the conjugate acid of sodium hydroxide is water. Take note of that, very, very important. Conjugate base of this. Conjugate base of everything we have there. So what will be the conjugate base of this? If you remove one hydrogen ion from this place, you're going to have, remember, we're supposed to have minus. So minus plus will cancel out, the thing will now be neutral. You're going to have NH3. If you remove one hydrogen from this one now, remove one from this minus again, minus 1 will give us minus 2. Then we have CO3 minus 2. Remove one hydrogen from this HF, you're going to have my HF raised to minus. Remove one hydrogen from this H2SO4, you're going to have HSO4 minus. Take note of the signs and how they are being formed. Let's look at more on this topic. Alright, basicity of an acid. Now, the basicity of an acid can be described as the number of repressible hydrogen ion present in a molecule of that acid. Number of repressible hydrogen ion present in the molecule of that acid. Let's say if we have HCl now, we have how many hydrogen ion can be replaced there? Just one hydrogen. Basicity will be 1. We have H2SO4, we have H2, 2 hydrogen there, basicity is 2, and so on. You have strong, weak, diluted, and concentrated acids and base. Now, strong means what is the strength of an acid, or how do we mean by when acid is strong or weak acid? A strong acid or a strong base is an acid that can ionize almost or completely in a solution. While a weak acid is an acid that ionizes just partially in a solution. So an acid that cannot ionize completely, that ionizes just partially in a solution, is called weak acid. Diluted acid is an acid that has more of the corresponding solution than the acid. While a concentrated acid is a concentrated acid, it's an acid that has more of the acid than the corresponding solution. So also with the base. Now, this KW you are seeing here, this equation you are seeing, is from the dissociation of water, where this K subscript W is called the ionic product of water. From ionic product of water, then at 25 degrees Celsius at room temperature, the ionic product of water will be equal to 1 times 10 to the power minus 14 mole square per dm6, in the sense that the concentration of both this hydrogen ion and hydrogen ion will be 10 to the power minus 7 mole per dm cube. Take note of that. Now the pH of a solution. The pH of a solution is the negative logarithm of hydrogen ion concentration. Let's say, for example, now if the hydrogen ion is 10 raised to power minus 3 mole per dm cube, the pH will be minus log of 10 raised to power minus 3, which will give us 3. Now, if you have a strong acid which do not dissociate completely, now one of the ingredients you need to calculate the pH of a solution is hydrogen ion concentration. If you want to get pH, what you need to get is the hydrogen ion concentration. Now, we have a substance that actually maybe is strong, but that will not dissociate completely. We have to get the dissociation, or the degree of dissociation. Then we now use the degree of its dissociation to multiply the concentration of that compound or substance. For example, the pH or the hydrogen ion concentration of that substance now will be equal to the concentration times degree of what? Dissociation. Let's say we have this question, e.g., let's say if the degree of dissociation in a 3 molar solution is a 3 molar, that's molar concentration, which is mole per dm cube, molar solution of hydrochloric acid is 0.05, what will be the pH and hydrogen ion concentration? Hydrogen ion concentration will be the concentration times the degree of dissociation, which will be this. Then the pH will be minus logarithm of that hydrogen ion concentration, which will be this. Note, relationship between pH and H plus hydrogen ion concentration is that hydrogen ion concentration must be equal to pH raised to 10 raised to power minus pH. Take note of that, which is the anti-log of negative pH. Then our H plus must be equal to 10 raised to power minus pH. This is the relationship between pH and H plus. That if you want to make H plus is subject to the formula, from that pH is equal to minus logarithm of H plus. Take note of that. Now, if, for example, let's say if pH is 3.2, if we have a pH of 3.2, what is the H plus hydrogen ion concentration? Hydrogen ion concentration will be equal to 10 raised to power minus 3.2, which is equal to 6.3 times 10 to the power minus 4 mole per dm cube. So this relationship between, if you want to make look for H plus in which you have pH given. Now let's look at more. Now, for a weak acid and base, for a weak acid, if you want to calculate the pH of a weak acid and base, then remember, for acid we are going to have hydrogen ion concentration, for base we are going to have hydroxy ion concentration. And for a weak acid, you are going to use this relation to get the pH, the hydrogen ion concentration first. Remember, if you have hydrogen ion concentration, you have already gotten your pH. If you have hydroxy ion concentration, you use the relationship from the dissociation of water to get your H plus, then you get your pH. Where K in this equation is called dissociation constant. That's what we call K, dissociation constant. So K over root of K, V is volume, so it's square root of K over V. And e.g., let's say if the dissociation constant of ethanoic acid is this is a dissociation constant, calculate the hydrogen ion concentration and the pH of a m over 100 solution of ethanoic acid. Now this describes the volume of the solution. This the volume is 100. So this expression describes the volume which will be imputing to this equation. So from the remember, ethanoic acid is a weak acid. So to get the H plus, we are going to do this relationship, the dissociation constant. You put them to that place you have it, that K. Just substitute the dissociation constant there. Then substitute your volume as 100. Use m over 100. Then you are going to have this. Then you have this. And after that, our H plus is this. Then pH is minus of H plus, which is 3.4. That will be the pH of the solution. Now, basically we say pH scale. Okay, we'll look at pH scale later. Let's look at more. Now, another question: if dissociation constant of ammonia is 1.8 times 10 to the minus 5 mole per dm cube, calculate the hydrogen ion concentration and pH of m over 1000 ammonia solution, which is NH3. That is formula for ammonia. Now remember that ammonia is a weak base, so to get the pH, now we are going to come from this OH to calculate the hydrogen ion concentration for a weak base. So the volume for this give terms of molar about 1000. The volume is 1000. is the zero constant. So substitute into this formula for this OH minus, you're going to have this. Then from that dissociation of water, you know that H plus times OH is going to give us 10 to the power minus 14. So H plus will now be 10 to the power minus 2 divided by OH minus. So our OH minus for this is this. So you just substitute into this, you're going to have this. Our H plus is this, and pH will now be minus log of H plus, which is this. That will be the pH of the solution. So now let's look at pH key to know if we have a pH of this range, if the solution is acidic or if it's a base. Now pH key. Now the pH key is actually used if you want to check whether a particular substance is acidic or basic. So the pH of a neutral substance is rate 7. For example, now the pH of water is 7. Then from 7 below to let's say 0, although some people say -3 to -0.3. From 7 to -0.3 should be acidic. Then from 7 to 14 should be basic. Upward to 14, move upward to 14. While some textbooks say from 7 to 14.5 is basic. Then right from 7 below to -0.3 is acidic. So please take note of that. So from what we have been servicing, anything below 7 is acidic, while those above 7 is basic. It's a base. That's how we use pH key for. Then buffer solution. What is the meaning of buffer solution? Buffer solution is a solution that maintains a constant fairly pH. Maintain a constant fairly pH if a little amount of alkali or acid is being added to it. It's being what? Added to it. So please take note of that. And to calculate the hydrogen ion concentration of the pH, you just take the dissociation constant multiplied by number of moles of acid there times number of moles of the salt. Number of what? Number of moles of what? Of the salt. And what is salt? Salt is just a compound is formed from the neutralization of acid and base, or is formed when the hydrogen part of an acid is being replaced by a metallic radical or any other radical. So you read about salts like acidic salt, basic salt, and other types of salts that we have. Then ensure you read more about this acid and base. Then check more about how to make a buffer solution, and so on. Thank you. God bless you.